Hi everyone, in this video I would like to explain the statement of the second shifting theorem on Laplace transform. Already you know that statement of the first shifting theorem on Laplace transforms. We discussed many problems in earlier videos. Please see that videos once. Now this is time for discuss the second shifting theorem statement. See. If Laplace transformation of a function f of t is a function of s, suppose f of t is a function in terms of t and its Laplace transform exists finitely, which is represented the function of s. It is a function of s, already know it, and g of t is another function. G of t is another function. So that g of t is function of t minus a. Here g of t is like in the form of f of t minus a if t is greater than a and it is 0 if t is less than a. Okay, so how is the structure of the g of t? G of t can be expressed in the form of function of t minus a if t is greater than a is any real number, and g of t is 0 if t value is particularly less than a. Then the Laplace transformation of this type of function g of t is equal to e power minus as into function of s. Here function of s is nothing but Laplace transformation of the function t. Don't forget it. So here I will reduce this function g of t, I will express this function g of t in the terms of unit step function also. See carefully. This is the another statement of the second shifting theorem. Suppose what is g of t here? Here g of t is f of t minus a. I will write this term as f of t minus a into 1 if t is greater than a. Okay, f of t minus a can be written as f of t minus a into 1 and 0 if t is less than a. So this can be written as in both parts, since the second term is 0, in both parts f of t minus a is a common term. So I will write here 1 0 if t is greater than a, if t is less than a. What is this? Already know it. This is nothing but unit step function. That's why g of t can be written as g of t is equal to f of t minus a into u of t minus a. So that's why according to the statement of second shifting theorem, you can replace g of t by f of t minus a into u of t minus a. So L of f of t minus a into u of t minus a. Suppose given function is like this, you can write the formula as e power minus as into f of s. What is the mean by f of s? F of s is nothing but Laplace transformation of the function t. L of f of t, simple. Okay, in this way we can define the statement of the second shifting theorem. Okay, see one example on this theorem. Now see. So this is the statement of the problem. If g of t is in the form of cos of t minus pi by 3. Here g of t is a function in terms of t which is defined as cos of t minus pi by 3. If this t value is greater than pi by 3, if t value is less than pi by 3, then function becomes 0. Okay, so we are going to find out the Laplace transformation of g of t. This is our aim. Here I will take f of t, I will define a function of t as, here right side we have a function in terms of cos. That's why I will take only f of t is equal to cos t. Also I will take a value as pi by 3, this point. Okay. So whenever you are taking f of t is equal to cos t, immediately g of t can be written as, how can we write the given function? Written as g of t is equal to, you can express g of t in terms of f. So f of t is equal to cos t, then what is f of t minus pi by 3? Cos of t minus pi by 3. F of t minus pi by 3. So cos of t minus pi by 3 becomes f of t minus pi by 3. That is the logic here. If t is greater than pi by 3 is equal to 0. If t is less than pi by 3. Now please compare this function g of t with the statement of second shifting theorem. If you compare this g of t with the statement of the second shifting theorem, then according to the second shifting theorem on Laplace, second shifting theorem on Laplace transform, what happened? L of g of t is equal to e power minus as into f of s. Take it equation number 1. So here what is f of s? F of s is nothing but Laplace transformation of function of t. What is f of t here? We are selecting f of t as cos t. So L of cos t. It would be s by s square plus 1. From the formula L of cos at, here a is equal to 1. That's why. Now replace this s by s square plus 1 in this formula. So according to this equation, L of g of t is equal to e power minus a. What is a value? A value is pi by 3. So e power minus pi by 3 into s into f of s is nothing but s by s square plus 1. So I will write this one as s into e power minus s pi. Otherwise you can write as s pi as you pi s as you wish by s square plus 1. In this way we can easily find out the Laplace transformation of the given function g of t. So in the next video I will give some more examples on Laplace transformations. Please subscribe my channel if you are watching first time of my channel. Thank you very much.